Hello, everyone. My name is Kagolo Fridaus, and we are Group 9, and today we are presenting our final year project report. We named it the Maki Legacy Academy, which is an interactive learning platform for teaching Python programming using it's block-based Python programming to children under the age of 12, between 6 and 12 years. Our platform is a clear path from Blookly exploration to Python confidence. Our core idea is simple. We are giving learners a clear, fun path from visual block-based coding all the way to writing real Python code. Next slide. Yeah, so our presentation roadmap, we're going to start with the context, which is why early programming education matters. Then we shall walk through the research, the platform itself, and finally the validation results. Next slide. It's a chance. All right, let's introduce what Maki Legacy Academy is. So Maki Legacy Academy was built around one key question: how do we make programming accessible to a child in Uganda who has never seen code before? The platform combines age-appropriate methods, block-based coding, and a smooth transition to Python. So it's also aligning with the academic standards of our country, and the goal is to make coding feel fun and relevant and not intimidating. So our platform is a innovative, academic, and practical solution. It aligns with the foundational digital skills and also accessible to learners. Next slide. We got into the global context. So, we all know programming education is no longer a simple skill or a niche skill. We've seen countries like the US, UK, and Singapore that have already integrated it in their primary education curriculum. They use tools like Scratch and Google Blockly to let kids explore coding visually before dealing with syntax. Python is we decided to start with Python because Python is particularly effective for beginners because its syntax is clean and readable. And globally, the direction is clear. Computational thinking belongs in primary education. So we are going to start with the young learners, the young kids, to embed computational thinking into them. Next slide. All right, Uganda's context. So in Uganda, the picture is quite different from the international countries. So in Uganda, ICT education focuses mostly on basic computer literacy. They learn things like word processing and browsing the internet, and most learners finish primary school without ever encountering a programming or computational thinking, without ever encountering programming or computational thinking. And that's the gap that this project targets to close. So infrastructure challenges are real, but they don't make the problem unsolvable. They make localized solutions more important. So we have a problem of scarcity of internet in Uganda, but that doesn't mean that people won't use the internet in Uganda. So Makidigasi Academy is here to try to fix that gap, to make learning, like it has an offline accessibility to the learners. Next slide. All right, the research gap. We've looked into the existing platforms. We have examples of the Code Academy, the Coursera, the Code.org, and among many others. And Code Academy is great, but it's built for older learners. Also, Coursera requires strong self-directed learning, which is unrealistic for a 7-year-old. We've seen Code.org that offers block-based coding, but it has very limited transition to Python. And none of these platforms were designed with Uganda's young learners in mind. Like there is a gap in cognitivity, culturally, and structurally. Next slide. Oh, my colleague will take over.
My name is Gukunda Stacy, and I'll be taking you through the primary learners need a localized path into programming. In that, Ugandan kids 6 to 12 can't learn coding properly because of the following. There is lack of programming education, just like Firdaus had said, whereby there's completely no coding in primary schools. Then there's inadequate ICT curriculum. Still on that same note, where there's no coding in the ICT curriculum of the primary kids, and they majorly focus on the literacy of ICT. Then unsuitable platforms, whereby foreign platforms don't fit in the Ugandan culture. There's also need for fast internet in those foreign platforms, and the English is highly advanced. Then digital skills gap, where there's a wide range and it keeps on widening with time. Next slide. Uh, so our goal or our objective of this whole Maki legacy is to build a localized coding platform for Ugandan kids, as Ridas had said. And then it bases on research phases where there's assessment, a need for assessment, system design, implementation, and also evaluation. Then it also focuses, there's an education and technical focus, whereby we combine the technical functionality with the way we teach the kids in school. Next slide. So the four objectives that we have that guide our platform into the discovery and onto the evaluation is we have to first identify the education gaps, whereby we research what's missing in the schools and we incorporate it in this platform. Then we design the infrastructure framework, whereby we come up with age appropriate lessons using the Google Blockly and simplified Python. Then we also build a prototype, which helps to develop the actual app. The whole essence of a prototype is to first go into the field, and then we can come up with evaluation and results onto getting the final result. Then we go on to evaluate how we test the kids and actually learn from them how to better the platform or how to adjust it with time. Then the next slide, we have mixed methods, where in the mixed methods approach, we combine the qualitative and quantitative methods. This is where we have stuff like interviews paired with surveys and test results. Then the quantitative techniques we have are interviews, observations. These capture what the kids or the teachers feel or say. For example, the voice instructions, were too fast or the voice instructions were too slow, then we can adjust. Then the quantitative measures, this is where we come up with the test results and they capture numbers. For example, 90% completed the lesson one in 12 minutes. So that means that it's easy or easy to grasp, which is very affordable. Then triangulation benefits. This is where we come up with the cross-checking of both types of data. If the kids say it's easy and the scores are also high, then that means that the findings are reliable and not just my opinion. Next slide. Then the hybrid agile prototyping. The main idea of the hybrid agile is to build once and launch. Then you keep on building in cycles so that you can fix problems early on in the development process. Then we have 4 steps in coming up with this. We have the requirements where we talk to the kids or teachers, then you capture what they actually need to code in class. Then you design where you turn those needs into app screens, lessons, and the flow. Then you test, you go on to test, you give the version to the kids, check if the buttons work, then if the lessons actually make sense to the kids. Then you go on to improve the whole system. You take their feedback, then you fix the bugs, then you also work on those confusing parts. Then you go on back to step one on the requirements. You keep on repeating till you come up with a final project platform. That's all I had. On to the next.
Hello everyone, my name is Sejanzi Elvis and I'm taking you through the development phases built from the foundation test to tested learning. One, we have the foundation of authentication. So since we need to secure the system, it is required that users to access the materials should be the ones who are the ones necessary to access the materials. So they should be first authenticated or given authority. One, to embed the Blookly learning mode. This is a visual programming mode for early learners to make the Python topics reliable and easy for them to interpret using the Blookly game. Then the Python learning mode. Basically, after learners grasping through Blookly, they are advanced to Python learning so that they can write their own code and see the results. Then role-based dashboards here. We embed dashboards and where teachers have their own dashboards to control the learners and the study materials, the admin dashboard and the learner dashboards. Then we have notifications and testing. The system should be able to give out notifications to users. So the stack that supports responsive learning, secure data and offline use. For front end, we are using React and Vite to create fast, responsive, efficient user interfaces. And for backend, we are using Supabase due to its simplicity with PostgreSQL. The learning materials, we have Google Blockly that will enable early learners, the young ones, to learn more easily and love what they are doing. We have the Monaco editor that will be used for writing Python code, among others. Then for offline communication, we are using Workbox that supports offline functionality in case one is in an area with low internet. The platform serves learners, teachers, and administrators, where learners will access their dashboard and will be able to use Blockly Lab, Python lesson, and they will also be able to track their progress and also view their achievements from what they are doing. Then the teachers will manage the learners and approve the submitted content. Then we will later monitor student performance and also print results. And the administrators will oversee the users and view the audit logs on the platform. Performance testing. After coming up with the system, we did performance testing where we did the initial load test, and our target was 3 seconds, and what we gained was 2.4 seconds, which is good for us. Then the block reload, our target was 2 seconds, and the result was 1.7 seconds. Then the offline execution, our target was also 30 seconds, and we managed to get 2.1 seconds. So security testing confirms protected areas and safe execution. We have the role for security, and here testing was confirmed where unauthorized users could not access the sensitive data. This will enable confidentiality of data since we take their bioinformation and which is confidential. Then the secure code sandboxes. Here, sandboxing minimizes the risks from the malicious or faulty code like cross-site scripting, among others. Authentication controls. The strong authentication will ensure that only authorized users can gain access to the system. This will enable us to protect the system from intruders who are unauthorized. Then data privacy. For privacy is kept throughout the system to ensure confidentiality of users' confidential data such as biodata, the date of birth, among others. So that's my next colleague take on.